Okay, so quick reminder. So the degree of a polynomial, so the degree is the highest power. So in this one here, when I'm pointing to, the degree would be the 5, because that's the highest power. So we're going to look at improper fractions. So that's when the degree of the top polynomial is bigger than or equal to the degree of the bottom polynomial, and we call that improper fraction. So we looked at this booklet about what can we do in that case, and we can divide it to get a quotient and a remainder. All we're going to do to begin with is just look at some examples and see if you can spot a pattern to do with the degrees. So the first two I filled in. So if my top polynomial, so my numerator is degree 5, my numerator is degree 3, and I divide them, this is what I get. So my quotient, this bit here, the degree is 2, and the remainder, this bit here, the degree is 1. Then if you look at the one underneath, this degree is 5, divided by degree 3, so 5 and 3. My quotient is 2, and my remainder, well, there's no x's, so the remainder is 0. Okay, so you might spot a pattern so far, you might not. Let's keep on. So this one, the top degree is 1, the bottom degree is 1. The quotient, well, there's no x's, so degree 0, and the remainder, again, there's no x's, so the remainder is degree 0. This one, the top degree is 2, degree in the bottom is 1. The quotient, the degree of 2x is 1, and the remainder, the degree 0, because there's no x's. Next one, top is 2, bottom is 2, quotient is 0, and remainder is 0. Top is 2, bottom is 2, quotient is 0, but this time the remainder is 1. Next one, top is 3, bottom's 1, quotient is 2, the remainder is 0. Next one, top is 3, bottom's 2, quotient is 1, the remainder is 0. Top is 3, bottom is 2, quotient is 1. This time the remainder is 1 as well. Next one, top is 3, bottom's 3, quotient 0, remainder 0. Next one, top is 3, bottom's 3, quotient 0, top is 1 this time. Next one, top is 3, bottom's 3, quotient 0, and the top is 2. So there's a couple more rows for you to have a play around with, so try your own if you want, and see if you can spot a pattern. Now, after you've had a play around, hopefully you'll spot that if the top is m and the bottom is n, the quotient is always just these two taken away. Now you can see that very quickly when you do the grid method. So if I did a quick grid, so if I had xm on the top and it was divided by xn, well, what do I divide times xn by to get xm? Well, it's xm minus 1. So when I times them, I'll add the powers, get my xm. And then the remainder, well, if you look here, these ones, the remainder could be 0, 1, 2, but it couldn't be 3. Here, it could be 0, 1, but it couldn't be 2. So here, the remainder is less than the degree of what I'm dividing by, so less than the degree of the polynomial d, so less than the degree of d. Yeah, and the degree of d, we call that one n, so it's less than n. Yeah, don't worry, this bit's confusing. It's just getting you ready for when we do stuff like this. So example 9. So we've got an improper fraction here because the top is degree 2 and the bottom will be degree 2. So using our rule before, the quotient should be 2 to equal 2 to 0. So I just have just no x's as quotient. And the remainder could be anything up to 2. sorry, less than 2. So it could be 0 or 1. So the remainder bit is the bit I can do the partial fractions on. So one method is I could divide this, get what A is, and then use partial fractions and remainder. Or I'm going to show you a way of doing it all in one go, then we'll do that other method on the next one. So to do it all in one go, same as before. So I'm going to times both sides by the denominator of the left-hand side. So I'm going to times both sides by x minus 1, x plus 2. So I'm going to get 2x squared plus 5x minus 10 is, well, a, when I times it by that, I just get a times x minus 1, x plus 2. B, when I times this by this, x minus 1's cancel out, so it's left with x plus 2. And the C, when I times that by that, the x plus 2's cancel out, so I just go left with the x minus 1. So same thing as before, choose clever values of x. So if I choose minus 1, if I sub minus 1 into there, I get 2 minus 5, so minus 3, minus 10, so minus 13. That's going to equal, well, if I sub, sorry, I should be subbing in x is 1, shouldn't I? Sorry, yeah, from there x is 1. So if I sub 1 into there, I get 2, 5 makes 7, take away 10, this is minus 3. So just minus 3, not minus 13, sorry. If I sub 1 into there, that gives me 0. So that thing is 0. If I sub 1 into there, that gives me 0. So just 1 into here, I need to sub into. So 1 add 2 is 3, so I get 3b. So minus 3 is 3b, therefore b is minus 1. Next one, this one here, x would be minus 2 there. So if I sub that in, I'm going to use my calculator this time so I don't make a stupid mistake. 2 lots of minus 2, if I can type, squared plus 5 lots of minus 2 minus 10. And again, if you spot any mistakes, make sure you tell me. So minus 12. If I sub minus 2 into this side, this will give me 0, so this whole thing will be 0. This will give me 0, so this whole thing will be 0. So let's get minus 2, take away 1, so minus 3, so minus 3c. Therefore, c equals 4. Okay, now you can see I've used all these up now. So in order to get a, well, to get a, I can just pick any number for x now. So I'm going to choose x is 0, because that's the easiest number I can think of. So the left-hand side becomes minus 10. And this side becomes, well, it's a times, it's going to give me minus 1, and that's going to give me 2. If I sub 0 into there, I'm just going to get 2b. If I sub 0 into there, I'm going to get minus 1c. Now the good thing is now though, I know what b and c are. So if I just simplify that, so I get minus 2a. B was minus 1 times 2 is minus 2. C is 4, so minus 4. Okay, so I get minus 10 is minus 2a minus 6. So now if I take the minus 6 to the side, minus 4 equals minus 2a. Divide by minus 2. So therefore a is just 2. So I've got my 3 values, my a, my b, and my c. So I get that my original fraction is 2 plus the b, which was minus 1, so minus 1 over x minus 1, plus the c, which was 4, so plus 4 over x plus 2. Okay, now a cheat way to get this 2 as well is if I looked at this, on the top I've got 2x squared, on the bottom I would have an x squared, so if I divided them, I'll just be left with a 2 there. So that's how I can get that really quickly as well. And you're allowed to do that if you can spot that. Otherwise, this is a nice safe method, which we'll use on the next video as well. Okay, and the last one to do with improper fractions. So make sure you're using your hand out because this is quite blurry, this one. See if we can zoom in a little bit. Nope, nothing's happening. Brilliant. Okay, so have a look at this one yourself. This bit here is a cubed. We're dividing by x cubed minus x. So the first thing I'm going to do is we have to show that can be written in that form. So that means divide. So I'm going to divide by x cubed minus x. I'm dividing x4 first of all. So x cubed times x4 gives me, sorry, x cubed times something gives me x4. So an x times minus x gives me minus x squared. Oh, now I wanted a minus x squared, so that's that done. So I've got the x4 in there. I've got the minus x squared in there. So the next thing in there is I need the 2. So that means I'm going to have a remainder of 2. So therefore, my fraction is x plus 2 over x cubed minus x. Yeah, because my remainder was 2. You see that? x4 minus x squared is in there. So my next number will be 2, but I can't put a 2 next to it because I can't times x cubed by anything to get the 2. So therefore, it's just my remainder. Okay, so then on part B, it is hence write it in partial fractions. Well, I could have used the trick from before, and if I used the trick from before, I would have brought it's on the bottom, it's x times x squared minus 1, which gives me on the bottom an x minus 1, x plus 1. So I could write, well, x4 take away x3. If x4 is on the top, x3 would be on the bottom. So my quotient would be a degree 1, so it would be something like ax plus b. And then my remainder bit could be split into partial fractions, would be something like c over x, d over x minus 1, plus e over x plus 1. This method here, I've got 5 unknowns, so it's a bit trickier this time. So instead, I'm going to go to part A, that's why they give me it. I'm going to use partial fractions just on that bit there. So I'm just going to look at 2 over x cubed minus x, we factorize there, x minus 1, x plus 1. And I'm going to write that as, I'm going to be sloppy and use these letters, so I'm just going to pretend that this bit I haven't written, so ignore that bit. So I'm going to write it as a over x plus b over x minus 1 plus c over x plus 1. Same tricks before, times both sides by x minus 1, x plus 1. So we get on the left-hand side, we get 2. Right-hand side be a this term. The x's cancel out, so we get x minus 1, x plus 1. The b, the x minus 1 cancels out, so I get bx, x plus 1. And on c, the x plus 1 cancels out, so let's get x minus 1. Pick clever numbers for x. So I'm going to pick 0 first of all. So this side, if I sub 0 in, I just get 2 still. If I sub 0 in there, I get minus 1 times 1, so it's minus 1, so minus a. That'll disappear, and that'll disappear. So therefore, a is minus 2. So the next clever number will be 1. So this side, it'll still just be 2. And this side, if I sub in 1, this will disappear. C will disappear, but b will give me 1 times 2, so I'll get 2b. Therefore, b is 1. And the last clever number is minus 1. So at this side, still just 2 because there's no x's. Minus 1, we'll make this 0. We'll make this 0. Let's get minus 1 times minus 2, which gives me positive 2, so 2c. Therefore, c is 1. So therefore, 2 over x minus 1, x plus 1 can be written as, well, a was minus 2, so it's minus 2 over x. B was 1, so plus 1 over x minus 1. And c was 1, so plus 1 over x plus 1. Then when I put that all together with part A up here, then my original fraction, my x4 take away x2 plus 2 for x cubed minus x, well, it can be written as the x plus this bit here. Now, since I put a plus, I'm just going to put the pluses first. So 1 over x minus 1 plus 1 over x plus 1, take away the 2 over x.